Hey everybody, thank you for watching this video. This video is an extension of part two of a blog series that I am doing where I'm talking about how I went about to uncover Windows security events. This is part one here. This video is going to cover explicitly the static analysis section of that blog post. If you haven't seen those blogs before, the project that I released was Telemetry Source, and this is just a way to track how different telemetry sources are generating their events. So where we're going to start with this is we're going to be looking at the scheduled task event within Windows security events, which I believe is 4698. And the reason why we're actually going to be focusing on that event is because I wrote another blog series a little while ago on WMI internals, and this is part three of that series. And at the very bottom here, you can see we stopped at SCH RPC registered task. And this blog series was simply to talk about how you have a PowerShell command that can go to WMI and then to COM and in turn RPC. Well, the reason why I want to talk about this is I thought that this would be a good way to kind of close off that series and kind of relate it back. That way, there isn't all this back and forth on how we got to this RPC function. So let's go ahead and dive right into it. So we are in IDA, and inside of here, we're looking at the SCH RPC registered task. We are within the schedule svc.dll, which you can find in C Windows System 32. Okay. Now, throughout this video, we are going to go forward with the thought that I've already annotated the majority of functions that I can annotate. We will run across documented functions and we will run across undocumented functions. Okay. But if you're not familiar with how to annotate those, it is as simple as going to the function you want. And so in this instance, we go to SCH RPC register task and we press Y. And then you go ahead and annotate that within here. Like I said, I've already done that and already put the definition for that. And once we press OK, it'll annotate that. And this process is super nice simply because it allows for following functions that may be undocumented to go ahead and annotate themselves as well. Where I got this information, so this is a documented function within Microsoft documentation, and so we can see here the definition for the SCH RPC register task. Cool. So with this, we kind of have to scope what we're looking for, and we are explicitly looking for anything that relates to auditing of the operation of registering a scheduled task. So here within SCH RPC register task, I am in the decompilation view and I see it makes another call to RPC register task. So if I double click on that, this is quite a big function. So instead of walking through each section, we're going to go ahead and go all the way down to where I know the auditing function is. But just kind of keep in mind, ideally, you would go through and try to figure out what this function is doing. And this is going to be doing a lot of different things on like getting the action set up, the triggers, etc. And then also part of the auditing, which we can see here on line 1705. Right there is this call to auditor audit job operation. So you'll see two of them here, and I'll jump on this here in a second and why you'll see two. But what's important to understand is try to identify the different parameters being passed in here. And here I see this interesting thing called a global pointer auditor. And that's what it is, just a global pointer. And I'm not really sure what this is quite yet. And so before jumping into this function, I might want to like do a cross reference to see what this is. Right. So I double click on that and then I press Control X, and that's going to let me see the cross references. And because I know that this has to do with some type of auditing event, I want to see if I can find where it was initialized or where it was like specified to begin with. And we can see it within startup auditing, and we press FN5, and that's going to let me see the decompilation view. It's just easier to read. So as you can see, I've been in here. I've already, like I mentioned, I've already annotated a lot. Within here, we see a lot of auth-z functions, specifically auth-z initialize audit event type. This is an undocumented function, but we do have the capability to document this. And this is because there is the leak source code on GitHub. So this is within a repository here. I'll link that in the blog. But if I look, I can go ahead and I can see the definition for this particular API, right? And so I can go ahead and kind of annotate that along the way. And that's kind of what I did with all the OSZ functions we wanted across, and any undocumented functions as well, as long as this documentation or this repository in turn actually had that information. So this looks like a lot going on. Simply what this is, you'll see that within here, there's different event IDs, right? And they usually come in like this hex value, but you can actually change the data type to be an unsigned integer here. And so all you need to know here, just so it doesn't get confusing, is that this is simply just a handle array. Okay, we can see the handle array, and then we can see the indexing here, and that's why if we go back over here, you'll see 0. That means it's going to be the index 0 if we go back over there here, and so it's going to be 4698. If we go here to the one below, we'll see a 2, and that's because it's going to be the second index within that, and so that will appropriately give back the handle needed for that information. So let's dive into this. This is the auditor audit job operation, excuse me. And so what we're going to do is we're going to go through here, and we see a lot of other OSZ information being exposed. Now, what's interesting here is there's actually 3. There's the OSZ initialized audit params, OSZ initialized audit event, and then OSZ log audit event. Excuse me. So I'm going to break down what these are doing, just kind of at a high level, and so that we can kind of move forward. We don't have to dive into each thing. So what OSZ initialized audit params is doing is simply just that. It's going to get the parameters that are needed that correlate with the actual operation in the event. So whenever you see like the event information within like 4698, this is kind of like where that package is up, and then it has to initialize that event and pass over the parameters for that, and then the handle as well, and then OSZ log audit event is going to take that handle and actually log. But when we double click on that, we don't see anything else. And so if we go inside of the imports here, we can see that OSZ log audit event is actually coming from OSZ.dll. So let's go into that. Cool. So I'm going to again look into the compilation, and I dive into this. And again, so with the scoping with this, I am explicitly just like, I'm not going to dive into each thing I did prior, but for this video and for the sake, I'm just going to expose the appropriate functions that will get us from point A to point B of how this event goes from operation to being written to the audit security event. So we get the Marshall audit params, but then if we go all the way down here, my scroller stopped working for a second. We see the OSZ psend audit to LSA. So this sounds really cool. This sounds to me like it's going to be sending this audit event. It is passing in the parameters. It's passing the handle. So this to me just makes me think like, okay, cool. This packaging all the information about the operation. It's packaging the handle to say what event it is, and then it's going to go to LSA. So if I double click on this, this is just some IDAism to say, hey, it wants to decompile. I see that this is going to make an NDR client call 3. Now, this is going to be a RPC function. I'm not going to dive into this just for the sake of time for this video. However, if you want to know how to actually figure out what interface ID this relates to and the method, I highly suggest going back to this blog post here, which is part 3 of the WMI, where I walk through that inside of IDA as well. So the process will be the exact same. But to save us some time, this is going to relate to a function within the LSA SRV.dll, which is going to be LSA RGen audit event. Okay, this event is going to, or this function, excuse me, is simply just going to call something else called LSA pgen audit event. Okay, and we see it's passing in the parameters and it's passing in the handle for the context. And so we double click on this. And this looks like it's purely just some type of audit event to specify, hey, these are the parameters that has to do with this specific event, and then package that up and send it accordingly. Excuse me. And so when looking at this, we see that a lot with here. We see that the flags are being set, category ID. So this lets me know like, hey, we're in a good spot. And then I see map audit event params. Great. Okay, so if we get context back, we're going to see that this function is called here LSA p ADT write log ex. and it's going to pass in the audit parameters, right? So we double click on that and we dive into this, okay? And then basically this is a pretty straightforward function. And we eventually going to get to the point where it's going to say like, hey, if the SE audit, if the pointer to the SE audit parameters is not null, go ahead and call this function ADTP write to ETW. Great. So I open that up and I go ahead and scroll through this as well. This is just a lot of event ID different logic here to say like do this if it's this event ID or higher than this event ID, etc. But that doesn't pertain to us right now. And then we eventually see that there is a function called ETW write security event. An event descriptor is passed through. And again, I was able to actually annotate this because there is a really cool guy that I have never met called Jeff Chappelle, who I believe, and Jeff, if you hear that and I said your name wrong, I apologize. But he's actually gone through, excuse me, and annotated a lot of these functions. So that's where I was able to actually get this information. And, this is quite common with ETW write or event write, which is in user mode as well. That the first parameter is going to be the event descriptor, and then you'll have the bottom, which is the structure for event data descriptor, which is basically going to be the data that correlates with that event. This is very common with any ETW based write event API. And so we see that here and we see that's going to be passed in, and great. So this is where we'll stop today. We have gone ahead and seen that whenever SEH RPC registered task is called, it eventually is going to create an audit event. And then this is going to be passed through multiple different functions, which started from that sched service.dll, which if you're not familiar, actually gets loaded inside of an SVC process that eventually gets passed into LSA SRV.dll, which is in the LSASS process, which imports this function from NTDLL and then goes ahead and writes this event. Now, there is a little bit more after this. We won't dive into it, but if you are curious, this will call another function called NTTraceEvent, but we won't get into that for this part. Thank you for watching. If you have any questions or anything like that, please reach out.